quick. Okay, so we're not probably really going to be able to ask a lot of questions unless it's like a quick 1 second question. Okay, here we go. So with something like this, it says simplify each polynomial and list all the excluded values. So remember to factor if possible and then restrict before you simplify. So looking at this one, I would restrict the bottom. So A cannot be 0, correct? And B cannot be 0 for this one, because that would make the denominator 0. So then we would simplify what we can. So 15 and 20 both divide by 5. So this would become a 3. This would become a 5. And then a to the 4th and a to the 5th, think about it. There's 4 a's on top, 5 on bottom. So a to the 4th would cancel out. And then, oh, you're right. 20 divides by 5 and becomes a 4, like you just said. Okay, good. And then this would become a to the 1st, right? And then there's 6 b's on top, 3 b's on bottom. So if you think about just dividing them out in sections, there would be 3 b's left on top, right? B to the 3rd. And then this would be gone. And so our final answer, you would say 3b cubed over 4a. As long as a cannot equal 0, b cannot equal 0, but it's going to be multiple choice, this portion. Okay, also, I might have you guys move this way because I'm going to be in the way and not worry about like opening up because we got to go so quick. So looking at number 2, for example, it says simplify and state the excluded values. We've got a fact at the top. What multiplies to be -3 and adds up to be -2. 1 times 3, -3. So the top factor is to be x plus 1, x minus 3. Making sure you can quick factor is really important. I can. And on bottom, what multiplies to be -6 and adds up to be -1. 3 times 2, -3, +2. So we can quick factor again. So I have x minus 3, x plus 2. Restrict before you divide. Do not miss all of these because you didn't restrict before you divide. So you'd say x cannot be 3 or -2 because that would make the denominator 0. And then those x minus 3's divide out. So my final answer would be x plus 1 over x plus 2, as long as x cannot equal 3 and -2, right? Nothing new to us. Okay. Like something of this difficulty level right here, so I'm scrolling up. The first thing you do with factoring is factor out a greatest common factor if possible. On top, I pull out an x, divide by x, divide by x, divide by x. So left is 4x squared plus 3x minus 1, right? Then from there, you'd say, I got to continue factoring the quadratic if possible, and it's going to be long factoring. Well, multiplies to be -4 and adds up to be 3. 1 times 4, and it's going to be -1. Then you got to drop and break. So really quickly, 4x squared minus 1. Do not mess up. You've got to be so careful on this test to not switch these and have this the wrong sign, because it's going to mess you up if you do. So you'll be making lots of little errors if you do that. Then I group. You guys know how to long factor. Pull out an x. Left is 4x minus 1. Pull out a 1. Left is 4x minus 1. So wouldn't I now pull out 4x minus 1? And then left is x plus 1. Okay. Now make a special spot where you put your final factored form. Do not forget something. That's where a lot of people mess up is people will forget. I factored out an x from the get-go. So I'm going to go right here and say, okay, I pull out an x. I have a 4x minus 1, and then I have an x plus 1. Just don't forget anything. And then on bottom, looks like I have a what in common? A 4. So I would like to pull out a 4 first if possible, because then it's going to be quick factoring. So I pull out my 4, but I'm going to change colors and do my work down here, because over here I'm putting my final factors. So I'm going to pull out a 4, then divide by 4, divide by 4, divide by 4. So then left is x squared minus x minus 2. Now I continue to factor that. What multiplies to be -2 and adds up to be -1. 1 times 2, -2, right? So on bottom, I pull out a 4. I have an x plus 1, and I have an x minus 2. Now I'll restrict before I divide. So I would say 4 is 4. It's never going to be 0. Good there. X just can't be -1. X cannot be 2. And then I'll divide out exact factors. It looks to me like in this example, those are the only things that divide out. So I say x, 4x plus 1, all over 4, and then x minus 2. That would be my final answer. Okay? All right. Oh, hey, question for you. if I asked you, this problem, Susie did the following. Is this okay? Looking at this problem right here. What was the mistake? Yeah, she divided across an addition sign, first of all, right? So we can only divide exact factors. So how would we correctly do this? Shouldn't I first factor out what's in common up here? And then things will divide out. But you cannot divide across an addition sign. So anyway, you know that. Here we go, something like number 5. All right, so still a good chance this will be multiple choice. When multiplying fractions, don't we multiply straight across? So you would have over 1. So on top I have 2. I have x squared minus 2x minus 3. And then on bottom I would have 2x squared plus x minus 1. Do not multiply 2 in, because your next step would be to factor, and you'd factor it right back out. Do not multiply them together. So you'll stop here and say, okay, that's my answer. Now I need to simplify my answer by factoring and dividing out exact factors, just like we did on the whole front page, right? Now we're to the step of simplification. So you factor. What multiplies to be -3 adds up to be -2. 1 times 3, -3. Be so careful, guys, not to mess up these things. Like, double check yourself multiple times to make sure we're good here. So then that quick factors, so I have a 2 on top, I have an x plus 1, and I have an x minus 3. Once again, asking, is everybody good? I know we're going fast, but this should be a final, like, I already know what you're doing, so if you go slow, I'm going to be annoyed because I would rather go quick. What multiplies to be -2 and adds up to be 1. Guess what people do? They get going too quick and they quick factor. It's long factoring here. So we would have 1 times 2, -1, correct? And these add up to be +1. So then quickly drop and break doing long factoring. So we would have 2x squared. We would have -1. Inserting these in, I'm going to go like this. Plus 2x minus 1x, group, pulling out what's in common here, running out of room, so I'm going to come down here, 2x, then left is, x plus 1, and then pulling out a -1 right here, right? Then left is x plus 1, safe haven's the same, so I pull out x plus 1, left is 2x minus 1. Now once again check, okay, I didn't have anything else on bottom besides that, so I'm going to go right here, x plus 1, 2x minus 1. It says simplify and state the excluded values. That's still the instructions here. What do you need to do before you, once again, divide out anything? Restrict. X cannot be -1, and what can it be, can't it be right there? Yeah, make sure you do the algebra. So set it equal to 0, you'd add 1, divide by 2, so +1/2. And then now we can divide out exact factors. So our answer would be 2x minus 3 over 2x minus 1. Can I divide those 2's? No, that would be dividing across a subtraction sign. That's it. So we're done. All right, this would be our final answer. Okay, are we good? Okay, looking at a division problem, you'd say, okay, dividing fractions is easy as pie. We flip the second fraction and multiply. Do not flip the second and multiply on multiplication. People start doing that, so only with division. So flip the second and multiply. So that would put x plus 1 on top, x minus 1 on bottom. And then when I multiply, don't I just multiply straight across? So I have right now 2x squared plus x minus 1 times x plus 1. And then on bottom, I have a 2 and an x minus 1. Do not multiply this out. You will be stuck. Stop and say, okay, that's my answer. Now I need to simplify my answer. We simplify all of these rationals by factoring and dividing out exact factors. So we would factor this. Did we already just factor that? So I did this on purpose just to make the early morning review quicker. So we already factored that a second ago to this, right? Is everybody good? Okay, so you would not have that on the test though. It's going to be something new, but we're good with factoring. So that factors to be, we have an x plus 1, we have a 2x minus 1, I just factored that. Then I have an x plus 1, don't I? Then on bottom we have a 2 and an x minus 1. So looking at this problem, we would, yeah, I have my 2 written. Did we pull, sorry, I think we're combining 2 of my problems with all my work here. So here's my original, so we're just here. So we didn't have anything. Does that make sense? Sorry about that. So then we would say, okay, our restrictions are x cannot be 1. The 2 is fine because there's no variable. Did anything divide out in this particular problem? No. Now, if that happens on the test, that could happen. But always that might be a hint that maybe we factored something wrong, possibly. So you could go back and double check, did I factor everything right? But if you did, be confident with your answer of it not dividing out. But a lot of times, that's a good hint that you've messed up somewhere too. Does that make sense? Okay, cool, moving on. No, so that would be my simplified answer, right? I'd be done. Okay, then next one. Okay, so next piece here is adding and subtracting. This would not be asking you to state the excluded values. So we would need a common denominator. X minus 1, x plus 4. That's our only denominator, right? An x minus 1 and an x plus 4. Because there's nothing in common, we would multiply by each other's denominator. So we multiply by x plus 4 over here, x minus 1, x minus 1. Always remembering that if you have two terms to throw parentheses in. Now we're going to focus on the numerator. 5 times x is 5x. 5 times 4 is 20. Negative 3 times x. Negative 3x. Okay. I'm giving up a dang cookie for you people. Okay, negative 3 times negative 1. Guess what people mess up on? They do not take and put the negative with the 3. They'll distribute it here, and then they'll just do 3 times negative 1 and write negative 3. That would be wrong, wouldn't it? We've got to take negative 3 times negative 1, which is positive 3. Now shouldn't we combine like terms? Because that's what we do with addition and subtraction, combine like terms. So you'd say 5x minus 3x is 2x, 20 plus 3. Plus 23, and that's all over x plus 4 and x minus 1. Now you're to the step where you say, that's my answer. Now I need to simplify my answer if possible. How do we simplify? We factor, divide out exact factors. Does the top factor? So nothing's going to divide out, so we're done. Everybody good? Okay, let's do another one. Looking at this one, guys, we want the least common, yes. Not with addition and subtraction. Okay, with this one on number 8, once again, we want least common denominator. So look, especially if you have a quadratic, there's a good hint that there's already something in common, you're just not seeing it. So we would need to factor out our denominator because there's probably secretly an x minus 3 already in there. Does that make sense? So let's see if that's true, because if not, we've seen problems where nothing was in common still, even when we factored. Well, let's check. Well, multiply to be negative 3, adds up to be negative 2, 1 times 3, negative 3. So rewrite the problem. We have 2x over, the bottom just factored to be x plus 1 and x minus 3. Then we have plus 3 over x minus 3. We already have an x minus 3 in common. We only need to fix it by multiplying by. Good. So now I'm fixing my denominator, multiplying by x plus 1, x plus 1. Once again, look at your denominators. If they're the same, you're good to go. Multiply out your numerator. So this, nothing changed. 3 times x is 3x, positive 3x. Positive 3 times positive 1 is plus 3. Now aren't we combining like terms? 2x plus 3x is 5x. So we have 5x plus 3 on top. On bottom we have x plus 1 and x minus 3, right? Now would be the time when you say, okay, that's my answer. Now I can simplify it if possible. We simplify by factoring the top, factoring the bottom, dividing out exact factors. The top doesn't factor, so we're done. Does everybody agree? Okay, sweet. Those are pretty simple compared to the review, right? Pretty similar to that difficulty level on the test. I know you can do this. Okay, sweet. Okay, we'll come back. Okay, continuing upward and onward. So let's read this problem. This is very similar to one we've had on our review. A rectangular prism has a height that is 2 more than 3 times the width. What is the length of the prism if the volume is this? So everybody, that's a lot of information. Go off to the side and say, okay, what are they giving me here? It says the height is 2 more than 3 times the width. You should start by saying, okay, well, that's interesting, but we don't even know what width is, so let's call width x. My length is 2 more than, so plus 2, 3 times the width. Oh, height. Okay, sweet. Change that variable. Height is equal to 2 more than, which is plus 2, 3 times the width. So 3x, 3 times the width plus 2. They always word it backwards. Okay. Now it says, what is the length? We don't know. Do not call it x, though. You can't say that the length's the same size as the width. We have no idea. So you've got to call it a different variable. We don't know what that is. Now it says the volume is this. So you should say to yourself, the true statement is volume is equal to length times width times height. My volume's that, so I have 3x cubed minus x squared minus 2x. That's going to equal our length, we don't know, times our width, which is x, times our height, which is 3x plus 2. What's my goal? To get question mark alone, correct. So what undoes multiplication division? So you divide by x, 3x plus 2. To both sides, divide by x, 3x plus 2. Now look, question marks alone, because these will divide out. You say, that's my answer, but I have to simplify my answer. We simplify these type of problems by factoring the top, factoring the bottom, and dividing out exact factors. We would never divide across an addition sign, right? So we'd factor out an x to begin with on top. Is everybody good up to here, though? Okay, I pull out an x on top, divide by x, divide by x, divide by x. Left is 3x squared minus x minus 2. Now you'd say, okay, I better check to see if this factors more. Well, multiplies to be -6 and adds up to be -1. 3 times 2, -3. Careful, we don't quick factor when your leading term is a 3. So you drop and break really quickly. 3x squared minus 2 minus 3x, putting these in, plus 2x. You guys know how to long factor. Pulling out a 3x, left is x minus 1, I believe. Pulling out a +2, left is x minus 1. So now I can pull out x minus 1, and left is 3x plus 2. 3x plus 2. So now you'd say, okay, on top, I won't forget that I had an x. I had an x minus 1 and a 3x plus 2. On bottom, I have an x and a 3x plus 2. And that's equal to my question mark, which is my length. Now, we're not going to restrict because it just said find the length. So we don't need to restrict. What is the length then? What divides out? Boom, 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 boom. So question mark must be x minus 1. Everybody good? Okay, we know how to do story problems because that is exactly what we learned. Okay, here we go. All right, back to this. So there'll be some free responses now where you have to do the same type of stuff. Multiplication, division, addition, and subtraction. Multiplying, don't we multiply straight across and put it in a pretty format for ourselves? So multiplying straight across. Because there's not multiple terms here, it might be pretty to call this 3 times 8. What is 3 times 8? Okay, so we have 24 on top, x squared. And then on bottom, we have 2x cubed. It says, state excluded values. Before you divide it out, we've got to exclude. X cannot be 0. Divide out exact factors. What's 24 divided by 2? 12 on top. And then x squared and x cubed, won't they divide out and become just x on bottom? So on top, we had a 12. On bottom, we had an x, as long as x cannot be 0. All good. Okay, looking at number 11. Dividing fractions, easy as pie. Flip the second and multiply. So we're going to have this stuff, x squared minus 2x minus 3 over 3x minus 9 times by x minus 1. Flip the second and multiply. So we have 2x squared minus 2x minus 4. Now we would just multiply straight across. So we have x squared minus 2x minus 3 times x minus 1 all over 3x minus 9 times 2x squared minus 2x minus 4. Now do not multiply that out. Once again, we say that's my answer. Now how do we simplify our answer? Factor and divide out exact factors. So from there we would factor it. We have factored this already a million times. So multiplies to be -3, adds up to be -2. 1 times 3, -3. So this quick factors to be x plus 1, x minus 3. What does that, oh, that's already factored, good to go. Now look, the top is still, look, it's the same problem. Everybody think about it. Multiplication is still multiplication. It's just rewriting this in factored form. Does everybody agree? All right, then on bottom, right here, I'm going to pull out a 3. Pull it out, divide by 3, divide by 3. Make sure you write it though. And then left is x minus 3. It's still multiplication. We have to long factor this. So it multiplies to be -8 and adds up to be -2. 4 times 2, -4. We would drop and break. I don't want to do it right here because it's fitting. This is where I'm putting my final factors. So long factoring that right here. Everybody try to watch. So 2x squared, -4. Then my middle two terms are these. So plus 2x minus 4x. Group. Pull out a 2x. Left is x plus 1. Pull out a -4. Left is x plus 1. Pull out x plus 1. Left is 2x minus 4. Ooh, we got to be careful. This one will trick people because guess what I didn't do from the get-go? I didn't pull out a 2 from the get-go, could I have? And then I would have been able to quick factor. But it's okay, because see, look, I'm going to catch myself. I'm going to say, okay, that's considered not factored completely. So don't I need to pull out a 2 at this point then? Now I'm going to put the 2 in front because that's prettier. So we pull out a 2 out of this, put it in front. We still have our x plus 1. And then if I pull out a 2, wouldn't that be x minus 2? It would have been quicker to pull out that 2 from the beginning. Too late. So I pull out a 2. Then I have an x plus 1 and an x minus 2. Now look at it. 3 times 2 is, so I'm going to erase that, come out here and go, okay, it's prettier to put 6. All right. This is still all multiplication, right? Okay, well, then you would restrict. X cannot be 3, -1, or 2. And now we would divide out exact factors. X minus 3's divide out, x plus 1's divide out, and that's it. So we have x minus 1 over 6 times x minus 2. Okay. Will someone shut that door back there? Thanks. Okay. Number 12. Is these two things the same? No. Just look. Let's look at it. You should say to yourself, this is y divided by 1. Dividing fractions easy as pie, flip the second and multiply. So on this one, we would have x times 1, which is x. Over here, we'd have 3 times y. This is the simplified answer, right? Then over here, we'd say, okay, this is x over 1. Dividing fractions easy as pie, flip the second and multiply. That puts y on top, 3 on bottom. So on top, I have xy. On bottom, I have a 3. They're not the same. I just showed by algebra. Okay. All right, add and subtract. So look at this one. We need a least common denominator. So think about it, guys. Can't you make 3 a 6? Can't you make x and x cubed? So I need to make all of the denominators 6x cubed, right? So what am I going to multiply by right here? Multiply by 2x squared, 2x squared. Now, once again, just verify that it's really the same denominator at this point. Yes, that's 6x cubed. Yes, that's 6x cubed. Okay, your next step is to multiply out the numerators. Nothing to do here. So 1 plus, what is this? 8x squared. So you'd say, okay, that's my answer all over 6x squared. Now you'd say, okay, technically, we should probably write it in standard form. And then how do we simplify? Factor out anything and divide out exact factors. 6x cubed. Let's just make that an ugly 3. So, looking at this, the top does not factor. You could try what multiplies to be 8 and adds up to be 0, nothing. So it doesn't factor, so nothing divides out. We would never divide across an addition sign, so we're good. Okay, next one. My least common denominator here would be x minus 1, x plus 2, right? X minus 1, x minus 1, right here. X plus 2, x plus 2. Look at your denominators. Are they truly the same? Looks good to me. Your next step is multiply out the numerator. 2x plus 4, am I right? And then negative 3 times x is negative 3x. Negative 3 times negative 1 plus 3. Combine like terms. 2x plus negative 3x is negative x. 4 plus 3 is plus 7. And then that's all over x plus 2 and x minus 1. You'd say that's my answer, but does my answer simplify? How do we simplify? We factor. So I'm going to pull out a negative 1. Left is x minus 7, am I right? Then on bottom, x plus 2, x minus 1. You know what? Nothing divides out. So this answer would have been acceptable. And this one, because they're equal, it's just we know for sure because it's factored that nothing divided out. Okay, all good. It's sweet. Okay, what is your final answer? Let's say we were adding or subtracting like in this problem, for example, and you got this as a final answer. How do we simplify? Factor and divide out exact factors, correct? So what would I pull out on top? Looks like a 4, then left is 5x minus 6, and then on bottom I pull out a 6, and left is x minus 6, right? Look, 4 and 6 simplify, so we better simplify those. They both divide by 2. 2 over 3, that's it. So we'd say 2, 5x minus 6 over 3, x minus 6. So just make sure when you get to your final answer to factor and divide out exact factors. Okay. All right, if I said to you, find the total area of these two pieces of the puzzle here. How do you find the area of this one? Length times width. So we would say x over 3 times x plus 2 over x, right? There's my area here. What's my area over here? You would do 3 over x minus 1 plus, times times 1 over 3. Now simplify those individually. Don't the x's divide out? So then my area over here would be x plus 2 over 3. What would my area over here be? The 3's divide out? 1 over x minus 1. How would you find the total area? Add them up, right? So then what would we need to do next? Get a least common denominator and put it all together. I'm going to move on. Is everybody good? All right, on to the graphing. Okay, good. This is good timing. Okay, here we go. So the first part is going to say, it's going to look exactly pretty much like this. So it says, find the points of discontinuity and then classify them as removable or non-removable. The points of discontinuity are what make the bottom 0. So we need to factor this all out. So pull out a 3 on top, left is x plus 2. On bottom, I would do what multiplies to be negative 10 and adds up to be negative 3. 5 times 2, negative 5, right? So the bottom factors to be x minus 5, x plus 2. Okay, let's say our discontinuities. X cannot be 5, x cannot be negative 2. These divide out, don't they? So that would make it a removable discontinuity. Does everybody understand? Now, this did not divide out. You didn't remove it out of the equation. Non-removable. If I said to you, what does that mean? You would say, if I said to you, what is a removable discontinuity and not removable? One's a whole, one's a vertical asymptote. Exactly. Okay, moving on. It says, what is the simplified expression for the rational? We would say, f of x is equal to 3 over x minus 5. List all the vertical asymptotes. Vertical was, like you just said, it was x equals 5, right? State all the holes. You guys, don't say 2. Negative 2 is where the discontinuity is. That's where the hole would be at negative 2 comma something, right? Don't we take negative 2 and plug it into the simplified function? So let's do that. We would do 3 over negative 2 minus 5. So wouldn't that be 3 over negative 7? So our answer would be negative 2 comma 3 over negative 7. 3 over negative 7. Find the horizontal asymptote. To find a horizontal asymptote, you want it in standard form. So let's look back here. This is in standard form. The rule is degree on top is smaller than degree on bottom, so it's going to be at y equals 0. If they were the same degree, this would have been an x squared. Then we would have said 3 over 1, right? Which is 3. Okay, moving on. State the domain. Easiest problem on the test. All real numbers except 5 and 2, negative 2, except x cannot equal 5 and negative 2. Easiest one on there, yes. You're not going to ever have the degree on top smaller than the degree on bottom in this class. So it will either be the same or the top will be smaller than the bottom in this class. Yes. It's the leading degree. You look at the leading degrees. So 1 is smaller than 2, so it's going to be 0. And if they're the same, it's going to be the leading coefficient, 3 over 1, for example. If they're both squared, it would be 3 over 1, which would be 3. Y equals. Okay, everybody, for horizontal asymptote, make sure you write y equals. Okay, now it says, identify the x-intercepts. This is all algebra. Everybody listen. You can use, for the x-intercept, the simplified function or the original. It does not matter, okay? So let's maybe just use the original, even though I want to say the simplified, because what if it didn't simplify? That's why I'm going to use the original. So you can always use the original. You can always use the simplified one. You'll get the same answer, but you might have to think a little more. So let's do the x-intercept. X-intercept is when y equals 0, correct? Isn't g of x y? Same thing. Okay, so x-intercept, you'd say to yourself, it's when y equals 0, plug in 0 for y. So we have 0 is equal to 3x plus 6 over all that stuff. Now remember, we've talked about so many times at this point that if we multiply it up by all that stuff, 0 times all that stuff is 0. So I'm going to stop here because we don't have time here. If you don't have that by now, ask someone before you get to the class. So, solve for x. How would we solve for x? We'd subtract 6, wouldn't we? Negative 6 equals 3x, divide by 3, so negative 2 equals x, correct? So we'd say to ourselves, our x-intercept is negative 2, 0, but now we just have to check one thing. Can negative 2 be in our domain? If yes, we're good. If not, we've got to throw that answer out. Does everybody understand? What was the two values we absolutely cannot be? -2. Well, then that's not going to be true. Does everybody see? You say, okay, never mind. No x-intercept. Okay, moving on. Identify the y-intercept. That's when x equals 0. Plug in 0 for x. You can do it to the simplified function or the original. It does not matter. You'll get the same answer. I'm going to plug it in right here because I scrolled up. So look. Now we're going to plug in 0 for x. 0 minus 5. So isn't that -3/5? So you would write it as an xy point. So you would say my y-intercept was x is 0, y is -3/5. Everybody good? Okay, moving on. Okay, match the graph below to the equation it represents. So what I would do instead is look at this and kind of go off to the side and kind of write your own equation. It's easier than trying to match it because it's easy to mess up. That kind of helps you start at least. So first of all, you'd say, I'm going to look for my discontinuities because that's the easiest to write. What are my discontinuities? The vertical asymptote. So you'd say, okay, x cannot be 3, correct? So on bottom, I'm going to have an x minus 3. Isn't that right? Then we would say, okay, our other discontinuities are wholes. So x cannot be 1, correct? So we have a hole at x minus 1, right? A discontinuity at x minus 1. Now to make it a hole, yeah, you need an x minus 1 on top. Now everybody understand. So you would kind of look and see which equation in those look just like that or are similar and have the same aspects to it. Does that make sense, everybody? Okay, cool. Would that change anything if I put a 4 in front here? No. So do you see what I'm saying? It could be a couple different equations, but just if you have that much, it's going to be really close to that. Everybody good? All right, moving on. It says, what are the horizontal asymptotes of the equation? Horizontal means not vertical. Vertical is the discontinuities, right? Horizontal means looking at it in standard form. Look at the degrees. What's the horizontal asymptote? So don't get tricked. This one's not in standard form. You need to put the top in standard form for horizontal asymptotes. So we'd say x squared plus 2x minus x. So that's plus x minus 2, right? And then over 3x squared plus 4x minus 5. What's my horizontal asymptote? The degree is the same. Look at the horizontal asymptote, 1 over 3. So you'd say y equals 1/3. There's only 2 rules to remember with that. Okay, what's my horizontal asymptote? Don't get tricked. This isn't in standard form. You can't compare these. So you'd multiply this out. I only care about the front thing, don't I? X to the first over x squared. So y equals 0, because the degree on top is smaller than the degree on bottom. Yes? No, that one had an oblique asymptote, so we haven't learned about those in our class. We won't have that on a test or anything. Yes. All right, so it says sketch the graph of the rational function. This is where I think it's going to be kind of hard because it doesn't break it down for you. I'm saying sketch the graph however you want, but guess what? There are steps you have to follow. Like first, go through the same steps and a little trick for yourself. Flip a few pages back and follow the steps that it led you through. Like in this problem, I basically lead you through how to graph it. So if you need to say how should these steps work out for me, go back and just follow these same rules and answer them. But once again, it's going to leave it open-ended. Sketch the graph. So the first thing we do is look for the discontinuities. Factor out the bottom. We'll multiply to be -3, adds up to be -2. 1 times 3, -3, right? We have x plus 1. I'm going to write it f of x. I'm going to write it properly. F of x is equal to x plus 1 over x plus 1, and then x minus 3. So we'd say x cannot be -1, x cannot be 3. This is a hole, and this is a vertical asymptote. So now I would go over to the vertical asymptote at 3, draw that in with a dotted line, obviously. I'm just trying to hurry because I don't want you to miss out on anything. Our hole is at, once again, -1, but you don't know where to go without finding your y value. -1 comma something. So don't we need to write down the simplified function? Simplified means we divided out what we could. So we have 1 over x minus 3, plug in -1. 1 over -1 minus 3. -1/4. So we would go -1 down a little bit and put an open hole that I can very well tell is an open hole. Okay, all good. Now from there, let's find the horizontal asymptote. Degree 1 is smaller than degree 2, so y equals 0, you would say, showing your work for me, horizontal asymptote. So then you'd go right here and draw that in. Then from there, you will plot x, you'll find x-intercepts, y-intercepts, or whatever, you know what I mean. You'll graph as many points as possible. So everybody, let's see if there is an x-intercept here. So we would say x-intercept is when y equals 0. So we'd have 0 equals x plus 1. The denominator doesn't matter, right? We've already established that. So don't we get negative 1? Can we have negative 1? Nope. So it's never crossing the x-intercept. None. Our y-intercept is when x equals 0. Y-intercept when x equals 0, so plug in 0. 0 plus 1 is 1. 0 squared minus 2 times 0, so that's 0. Negative 3. So now we'll go over 0, down a third, correct? Now you would plot in your calculator, you would type it in. I highly recommend in your calculator, if you're going to type it in, have it in standard form. You need parentheses here and here. Plot as many points as possible. You should have a graph either here, 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 here. But you should have a graph on this side of the vertical asymptote and on this side somewhere. Yes. Because we got that it was negative 1, right? And it just, in this problem, that happens to be a discontinuity. So now what's going to happen is, we know it's not crossing the the x-axis, so it's coming down by the asymptotes, right? And then it's either going to be right here or up here. And once again, so what would I do? I look at 4, and if it's up here, we know it's up here. Okay, all good. Okay, moving on. It said, what are the solutions of the rational equation? You'd say to yourself, I need a least common denominator. Once again, x minus 1, x plus 1. If you don't factor that, you're going to miss that there's already an x plus 1 and an x minus 1 in this problem. Do not get a huge equation or you're not going to be able to solve it. So you'd say, I better factor this because there might already be stuff in common I'm not seeing. So we would have x over x plus 1 plus x over x minus 1 equals 2 over, yep, x plus 1, x minus 1. You know how to factor that quadratic, correct, everybody? Okay. So what's my least common denominator? Don't overthink it. Look at it. X plus 1, x minus 1, right? So then, yes, we need to multiply this one by x plus 1, x plus 1, x minus 1, x minus 1, right? Now look and make sure they're all the same denominator. Yup, yup, yup. Because there's an equal sign, and only if there's an equal sign, you can now ignore the denominator. Solve using the numerator. So you'd multiply this out, x squared minus x plus x squared plus x equals 2. How do we solve this? Combine things. What's x squared plus x squared? 2x squared minus, negative x plus x. So 2x squared equals 2. It's a quadratic. Now in some quadratics we have to factor, but in this one, we just solve, right? Divide by 2. So x squared equals 1, square root both sides, x is equal to plus and minus 1, correct? Then when you check it, guess what? Yes. Yes. Well, you guys, you three, you gentlemen, let her help get those desks and maybe help her. And then there's some up here. So yeah, I do have. Yep. Okay guys, so then we would check them by plugging them back into the original. So look what happens. If I plug in 1, I'd have 1 over 2, correct? 1 plus 1. Yep. And then plus 1 over, what's 1 minus 1? Can we divide by 0? Oh, dang nabbit. We've got to throw out, we got to throw that one out, right? Extraneous. Because that can't be true. Okay, I'm going to check negative 1. So right here, we would have x equals 1. We'd just say, no, it's extraneous. That's how you write it. Checking negative 1. So look, negative 1 plus 1 is 0, right? Once again, isn't that extraneous? Yep, so x equals negative 1 isn't true. It's extraneous. So in this problem, there is no solution. All good. Okay. Moving on, look at this one. You say I need a least common denominator. Do not be mistaken. There is no way to make negative 2x plus 2. No way. So we have to just multiply by X minus 2, X minus 2. X plus 2, X plus 2. This one needs X minus 2, good. X plus 2, X minus 2, X plus 2. Now you'd say, okay, my denominators are the same. Because there's an equal sign, I can ignore the denominators. So now you multiply this in. 2x minus 4 plus x squared plus 2x. That equals, multiplying this out, we would get x squared. Now, isn't this times 1? But even if it wasn't times 1, I'd multiply these two together, combine like terms, and then multiply 1 in, right? Okay, or whatever the number is. So we have x squared plus 2x minus 4. The plus 2x and minus 2x cancel out in this problem. I'm kind of hurrying because we're running out of time. So then from there, we're gonna solve for x. So we need to combine like terms. Subtract x squared, subtract x squared. So we have 2x minus 4. Didn't those cancel out? Hallelujah! We don't have to solve a quadratic. So we have 2x minus 4 plus 2x equals negative 4. Right? Solve for x. So shouldn't I combine these? 4x minus 4 equals negative 4. So we'd add 4, 4x equals 0, divide by 4, x equals 0 in this one. So it's just algebra. So then we would plug in 0 and check it, all is good. If it's linear though, remember how we talked about it? If it's linear, it's not going to be extraneous. We were solving a linear equation, weren't we? So you're good. Yeah. To the original. 2 over 0 plus 2, which is, we have a 1 plus 0 divided by anything is 0. You can have 0 on top, right? And that equals 1. Is that a true statement? 1 equals 1, so it's not extraneous. But like I said, if it's linear, if you're solving a linear, it's not going to be. Okay, cool. That's really it. I mean, basically it. This is my pretty much last example. Find a least common denominator. So wouldn't it be 6x? So you'd say I need to multiply this by 3, right? If we're making them 6x. This one would need to be multiplied by 2x. 2x. This one needs a 6, and this one needs a x. Look at your denominators. If they're really all 6x, we can then ignore them. Solve using the top. 15 minus 4x equals 1 times 6. 6 plus 5x. It's linear. So we'd say I'm going to add 4x. So I have 15 equals 6 plus 9x, right? Subtract 6. 9 equals 9x. So x equals 1. Okay. So it's really not going to be much harder than that. Okay. So once again, if I said to you, which you guys nailed it today, you're going to do awesome. What are the removable discontinuities? What are the non-removable discontinuities? You say x cannot be negative 2. Do not say that do not say 2 is a removable discontinuity. That's wrong. It's negative 2. That's the discontinuity. So you call this removable, so it's a whole. X cannot be 1 is a vertical asymptote, non-removable. Everybody good? You're going to do awesome. That was the end of it. Wholes or vertical asymptotes.